Imagine pressing a simple rubber stamp onto a sheet of paper. In less than a second, a perfect design appears as if by magic. But here's what nobody tells you. Before that tiny stamp ever reaches your desk, it travels through mines, chemical plants, high-tech factories, precision engraving machines, and skilled human hands. Today, you're about to discover a manufacturing journey hidden in plain sight. Most people never think about this, but billions of documents around the world still rely on rubber stamps every single year. Banks, hospitals, schools, government offices, warehouses, and factories all depend on these small tools for speed and accuracy. What happens next surprised even experienced engineers, because the real story begins thousands of kilometers away from the factory floor. Think about this. A single rubber stamp combines natural resources from different parts of the world with precision engineering measured in fractions of a millimeter. Every line, every letter, and every tiny detail must survive thousands of impressions without losing its shape. And that's only the beginning of this incredible journey. The journey starts in tropical rubber plantations across Thailand, Indonesia, Vietnam, and Malaysia, where millions of rubber trees produce the milky white latex that makes flexible rubber possible. Workers carefully score the bark before sunrise because cooler temperatures allow the latex to flow longer. A mature tree can produce latex for more than 20 years, but only if every cut stays precise. Imagine thousands of trees standing silently while each drop begins its journey toward becoming a rubber stamp. Fresh latex contains roughly 60% water and about 35% natural rubber, along with tiny amounts of proteins and minerals. At nearby processing facilities, workers add controlled amounts of acid to separate the rubber from the liquid. The rubber then passes through heavy rollers that squeeze away moisture before large drying systems prepare it for transport. The sweet smell of fresh latex slowly changes into the rich scent of processed rubber. But natural rubber isn't the only ingredient. Many modern stamps also use synthetic rubber made from petroleum-based chemicals produced in countries like the United States, South Korea, Germany, China, and Saudi Arabia. Engineers blend different rubber compounds to create the perfect balance between softness, durability, and sharp image quality. That special recipe decides whether a stamp lasts for hundreds or hundreds of thousands of impressions. The handle tells another fascinating story. Wooden stamp handles often begin as sustainably harvested beech, maple, or birch logs from managed forests across Europe and North America. Other manufacturers choose recycled engineering plastics molded into ergonomic shapes that resist cracking after years of daily use. Every material faces strict inspections before production can even begin. Meanwhile, tiny amounts of steel, aluminum, springs, pigments, adhesives, and industrial inks arrive from specialized suppliers around the world. Some shipments travel thousands of kilometers by cargo ship before reaching the assembly plant. Most people never think about this hidden supply chain, yet a missing spring no bigger than your fingertip can stop an entire production line. And the next stage reveals how all these ordinary materials transform into something surprisingly precise. Now the factory truly comes alive. Long before the first stamp takes shape, powerful internal mixers blend natural and synthetic rubber with carbon black, curing agents, sulfur, and processing oils. Inside the mixing chamber, temperatures climb to around 110 degrees Celsius 230 degrees Fahrenheit, while massive rotors spin at nearly 40 revolutions per minute for 8 to 12 minutes, folding the ingredients into a perfectly uniform compound. The deep rumble of the mixer shakes the floor, and the warm scent of fresh rubber fills the air. The soft rubber compound now moves through a precision rolling mill. Two polished steel rollers squeeze and stretch the material into smooth sheets with an even thickness, usually between 2 and 4 millimeters. The rollers rotate continuously, pulling the rubber forward with incredible accuracy while every tiny air bubble disappears. What looks simple here will determine how sharp every future stamp impression becomes. Next comes one of the most fascinating moments in the entire factory. Designers convert logos, signatures, and text into digital artwork before high-powered laser engraving systems carve every microscopic detail into special rubber sheets. The focused laser beam moves with astonishing precision, burning away material in seconds while producing wisps of smoke that disappear into powerful extraction systems. Imagine thousands of tiny letters forming one perfect image without a single blade touching the surface. Some factories still rely on traditional molding techniques for standard stamp designs. Workers place engraved molds into hydraulic presses where temperatures reach approximately 160 degrees Celsius (320 degrees Fahrenheit) under pressures of nearly 150 bar, or more than 2,100 psi. During the next 8 to 15 minutes, sulfur creates strong molecular bridges between rubber chains, transforming the soft compound into a durable elastic material. And this chemical change gives every stamp its remarkable strength. After cooling, automated cutting machines separate each stamp with incredible precision. High-speed steel blades and CNC-guided cutters move at remarkable speed, producing thousands of perfectly shaped rubber dies every hour. The sharp clicking sound echoes across the production floor while robotic arms neatly stack each finished piece into organized trays. Every movement looks almost like a perfectly choreographed dance. Now everything finally comes together. Skilled workers and robotic assembly stations carefully bond the engraved rubber die onto its matching base using industrial adhesives that cure within minutes. Springs, self-inking mechanisms, ink pads, and protective covers slide into place with satisfying mechanical clicks. You can almost hear hundreds of perfectly synchronized machines building thousands of stamps every single hour. Now everything finally comes together. Skilled workers and robotic assembly stations carefully bond the engraved rubber die onto its matching base using industrial adhesives that cure within minutes. Springs, self-inking mechanisms, ink pads, and protective covers slide into place with satisfying mechanical clicks. You can almost hear hundreds of perfectly synchronized machines building thousands of stamps every single hour. Before any stamp earns the right to leave the factory, it receives its very first impression. Fresh ink spreads evenly across the engraved surface before the stamp presses firmly onto bright white paper, revealing every letter, line, and tiny detail. One blurred edge or missing mark sends the product back for adjustment. But here's the question that keeps every engineer awake. How do manufacturers guarantee that the 10,000th impression looks just as perfect as the first? That's exactly where our journey heads next. This is where an ordinary factory becomes a precision laboratory. Every finished rubber stamp enters a fully automated inspection line where AI-powered vision cameras examine each product from multiple angles in just a fraction of a second. High-resolution sensors compare every letter, line, and curve against the original digital design, measuring details as small as 0.05 millimeters. What looks perfect to your eye can still fail the machine's incredibly strict standards. Laser measuring systems now take over. Invisible beams sweep across the engraved rubber surface, checking the depth of every character and the flatness of the stamping face with micron-level precision. Even a tiny defect can cause uneven ink transfer, turning a crisp signature into a blurry mess. Most people never think about this, but one microscopic flaw can ruin thousands of important documents. Next comes the durability test. Automated machines press each sample stamp against paper over and over again, sometimes 20,000 to 50,000 impressions without stopping. Pneumatic cylinders cycle at remarkable speed while sensors monitor pressure, alignment, and ink consistency every single time. The rhythmic thumping fills the testing room like the heartbeat of the factory. The ink faces its own challenge. Engineers test whether it dries quickly, resists smudging, and maintains clear color after months of storage. Samples sit inside environmental chambers where temperatures swing from -20 degrees Celsius -4 degrees Fahrenheit to 60 degrees Celsius 140 degrees Fahrenheit, and humidity rises above 90%. If the ink fades, bleeds, or thickens, the entire batch gets rejected. But here's something extraordinary. Even with advanced robotics and artificial intelligence, one final inspection often depends on experienced human hands. Skilled technicians gently press the stamp onto premium paper, instantly recognizing subtle imperfections in pressure, texture, or ink flow that even sophisticated machines can occasionally miss. Years of experience still outperform technology in this final moment of truth. Only after passing every inspection does the stamp move to final packaging. Robotic arms place finished products into protective boxes while automated label printers apply batch numbers and tracking codes for complete traceability. Every package carries the story of hundreds of precise manufacturing steps, hidden inside a tool that fits in the palm of your hand. But the biggest surprise isn't inside the factory. It's the incredible scale of the global industry waiting beyond these doors. Now let's step outside the factory and look at the bigger picture. Every year, manufacturers around the world produce hundreds of millions of rubber stamps, serving offices, schools, banks, hospitals, logistics companies, and government agencies. The global stamp and marking products industry is worth billions of US dollars, proving that even in the digital age, a simple stamp remains an essential tool. Imagine lining up 1 year's production. It would stretch farther than many of the world's longest highways. China leads global production thanks to its enormous manufacturing capacity, followed by countries such as India, Japan, Germany, and the United States, each specializing in different types of stamping products. Together, these nations employ hundreds of thousands of workers across rubber processing, plastics, tooling, printing, assembly, and distribution. Every finished stamp represents the combined effort of miners, chemists, engineers, machine operators, designers, and inspectors working across continents. Most people never think about how many hands contribute to such a small product. The story of the rubber stamp began in the 19th century, when businesses needed a faster way to mark documents. Early stamps were carved by hand, and every design demanded hours of skilled craftsmanship. Over the last 50 years, laser engraving, CNC machining, CAD software, robotics, and AI inspection have transformed production into a high-speed precision industry. What once took an artisan an entire day can now happen in just a few minutes. Did you know that many premium self-inking stamps can deliver more than 50,000 clean impressions before major replacement parts are needed? Did you know that modern laser engraving systems can reproduce text so small it remains readable only with magnification? And here's another surprise. Even as electronic signatures grow more common, demand for specialized industrial, medical, and security stamps continues to expand worldwide. The future of stamping is becoming smarter, faster, and more sustainable with recycled plastics, cleaner inks, and increasingly automated factories. From quiet rubber plantations to roaring factories filled with lasers, robots, and skilled technicians, you've followed the complete journey of one of the world's most overlooked tools. The next time you see a crisp impression appear on paper, you'll know it represents science, engineering, craftsmanship, and a global supply chain working together with extraordinary precision. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.